All right, well, now that we have been rocking the second derivative and how it affects our original function, it's time to talk about speed. What is speed and how do we know if speed's increasing or decreasing? So speed is the absolute value of velocity. Think of it this way. Whether you're driving a car to the right, which would be a positive, let's say 30 miles an hour, or driving to the left, which would be a negative 30 miles per hour, your speed would be 30. Velocity takes into account direction and how fast you're going. Speed is just how fast. So it'd be the absolute value of velocity. Now, when is speed increasing or decreasing? I got an activity for that, and then we'll do a problem with actual numbers and functions. Given a particle is moving along the x-axis, so we're moving right and left, with position given by the twice differentiable function x of t, meaning the derivative is continuous, both the first and the second. Under which of the following conditions is the particle's speed increasing and decreasing? I'm asking you to walk it out. All right, well, this first scenario here, it says x prime is greater than 0 and x double prime is also greater than 0. So if x prime is greater than 0, we're moving to the right. Okay. If x double prime is also greater than 0, think of it as not only are you moving to the right, but you're being pushed to the right. So if you're moving to the right and being pushed in that direction, you're going to be speeding up in the positive direction. That's it. So speed is increasing. I'm going to go the opposite there. What happens if your derivative, the velocity, is less than 0? Well, then you're moving to the left in the negative direction. And if acceleration, x double prime of t, is less than 0, then you're also being pushed in that direction. So we're going back and being pushed. We're speeding up in the negative direction there. That's not bad. So that's going to be, well, not decreasing, sorry, that's going to be increasing speed. That's all there is to it. So basically, if the signs of velocity and acceleration are the same, you are speeding up, or your speed is increasing. So what happens when the signs are different? Well, let's look at x prime being greater than 0 and x double prime less than 0. So if x prime is greater than 0, you're walking to the right. But if the acceleration, x double prime, is less than 0, you're being pushed that way. So it's like I'm going this way and being pushed that way, slowing down. So your speed is decreasing, or you're slowing down. It's interesting, right? I think it's very cool. And last but not least, if x prime is less than 0, that means that we are moving now to the left. But if x double prime is greater than 0, we're being pushed that way. So walking this way, but being pushed that way, slowing down, right? So that's like driving backwards and braking. So that would be a speed decreasing. So when the signs of velocity and acceleration are different, they're fighting against each other, we're slowing down in speed. When the signs of velocity and acceleration are the same, positive and positive, negative and negative, here and here, our speed is increasing. They're working together. That's it. Think of acceleration as the direction in which you're being pushed. That's sweet. I love it. Let's make it simple. Okay, on to the next part. How do we use this information now? Well, let s of t equal that function represent the position of a flea. Of course it would be a flea. It comes out of my brain, right? On a horizontal path for time t on the interval 0, 7. On what interval is the flea's velocity increasing or decreasing? Justify your answers. Okay, so first things first, we've got to find basically where the position, well, where it's going to the right or going to the left. So we've got to find the velocities, and we've got to figure out the acceleration. So let's figure out both. So s prime of t, a little bit of work to do here, is equal to 4t cubed minus 6t squared. We're going to figure out where that's 0, because that's going to tell us what's going on. So we've got the GCF here is going to be 2t squared times 2t minus, and then this will just be, I think 3. That's all. Equal to 0. So we've got t equal to 0 and t equals to 3/2 are the two places where we could possibly change direction. Now, I'm going to overlay the first derivative and second derivative because those are your positions and velocities, right? S prime of t, which is v of t. And we're going from 0 to 7 here. The only value I really need to check then is 3/2 because 0 is one of the endpoints right here. So let's test some values. 1. If I plug 1 into this velocity, I get 2. And then here I get a negative value, so it's going to be negative. So we're moving to the left here. And then from 3/2 to 7, 6. Positive, positive. That's positive. So we're moving to the right now. Okay, well now let's check this out. S double prime of t, that derivative is going to be the derivative of this, which will be 12t squared minus 12t. Again, set it equal to 0. We want to figure out what its signs are doing. So 12t GCF times t minus 1 equals to 0. And again, we'd have t equals 0 and t equal to 1 where the sign of the acceleration could change. All right, I'm going to do that in a different color. So we do out another number chart here, another sign chart. 0 to 7 are our end points. Notice I didn't check anything outside of that. There's no point. And then at 1. Now I'm going to put 1 right here, so it's a little bit below. It lines up with our sign chart up there so as not to confuse us later. I'll plug in 0.5. Positive, 0.5 minus 1 is negative, so we're negative from 0 to 1. That means that we're being pushed to the left on that interval. And then value of 6 again. Positive, positive, positive. That means we're being pushed to the right here. Okay, so I'm going to just state right here, speed increases. And where does it increase? Well, it's going to increase whenever the signs are the same. So that would be from 0 to 1, right? That's happening where they're both negative. Increases on 0 to 1. And where else? I'm going to draw this little line right here. Because from 3/2 to 7, both curves, s prime and s double prime of t, which is the acceleration, are positive. So, and 3/2 to 7, since, and we'll say s prime of t and s double prime of t have the same signs. Have same signs. I'm going to need to borrow some room for the next part of the problem. Okay, speed is decreasing. Where is it decreasing? Well, let's take a look. It's going to be decreasing where the signs are opposite. Well, we've already kind of taken out most of everything else, but here, velocity is negative, and here, acceleration is positive. It's positive from 1 to 7. So it's between just 1 to 3/2. So speed is decreasing from 1 to 3/2, since v of t, or s prime of t, we've defined them both, and a of t have opposite signs. That's it. That's all there is to it. And I'll abbreviate the heck out of that. All right, that's speed. Speed is all about, are the velocity and acceleration, do they have the same sign or opposite signs? Is the flea's speed increasing or decreasing at t equals 2? Justify your answer. So let's find both. Here's how you would do this kind of problem. S prime of 2, actually the last problem was tougher. S prime of 2, and I'll just say since S prime of 2 is equal to, well, if I plug in S prime of 2, I'll get 4 times 2 cubed minus 6 times 2 squared. All right, well, that's 8 times 4 is 32, minus 24 is equal to 8, which is greater than 0. That's what we care about, is the sign. And S double prime of 2, which is equal to, we'll plug that in, that's going to be 12 times 2 squared is 48 minus 24 is 24. And that's greater than 0. Then the flea's speed, and just copy this part at this point, the flea's speed is increasing at t equals 2. That's a justification as well as a conclusion. You've determined that since the derivative of the position at 2 is greater than 0, and the second derivative at 2 is greater than 0, the flea's speed is increasing at t equals 2. That's all that has to be stated. Notice that we've got to actually plug in the number there and show the numerical evidence, or at least show that the number itself is greater than 0. You can't just state S prime of 2 is greater than 0. How do you know? Oh, there's the number. That's how I know. All right, that's it. I'll see you in the exercises. Speed increasing or decreasing? You got this.